talk about using climate engineering through solar radiation management as a way to potentially address unexpectedly bad climate change. The effects of climate change are uncertain, and so people have talked about using climate engineering as a kind of insurance against worse than expected rates of change. In this paper, we used high climate sensitivity of a model as a sort of proxy for situations under which we're more likely to implement climate engineering. We did this through a perturbed physics ensemble in which we vary a lot of the parameters of the model to look at effects under different climate sensitivities. For the results, we looked at regional rates of change. So basically, in different regions, we looked at the rate of temperature change and the rate of precipitation change with and without SRM, or climate engineering stabilization. What we found is that in terms of regional rates of temperature change, there's no difference in how well SRM works at stabilizing regional rates of temperature change. And we also found that SRM works equally well at any point in the simulation. So basically, as greenhouse gases continue to rise in our simulation and we use more SRM to compensate, as long as we're canceling the forcings from greenhouse gases with SRM, at any point in the model you can reduce the regional rates of change equally well, independent of climate sensitivity of the model. In terms of regional rates of precipitation change, we found that there was a statistically significant higher rate of precipitation change in the SRM stabilized regional climates than in the low climate sensitivity models. But we found that relative to a no SRM alternative, it actually worked better, SRM, in the high climate sensitivity models than the low sensitivity models. Basically, the regional rates of precipitation change after applying SRM were more than 50% lower on average than in the simulations where there is no climate engineering.